Welcome back to lesson number 2. Looking at class example number 5, we're looking at keying in the sequences in order to find the angles. So write the keying sequence which will determine the acute measure of the angle 80 degrees if sine A is equal to 0.3584. Now sometimes your keying sequence might look a little bit different, so I'll write what two potential keying sequences could be. So first of all, you might have to type in the ratio first. So I'm just going to do this as if this was one key, but 0.3584, that might be the first thing you need to do, is type in the ratio. Then the next thing you might need to do is type in your second function. Then you might have to type in sine, and then you might have to close a bracket. So I'll put a bracket button there, and then you would press your enter button. So this is one way you might have to do it. The other way is you start with your second function, just like in the above example here, and then you would type in sine, and then you would type in your 0.3584. Then you would close your bracket, and then you would hit enter. So unfortunately, I only have one type of calculator on my desk at the moment, so I'll show you how you probably, if you have a model similar to this is how you would do it. You would first hit your second button, in this case, and then I would press inverse sine, and then I would go 0.3584, and I close my bracket, and I get a value of 21 degrees. And we're going to the nearest angle here. So A is equal to 21 degrees. Cosine B is, and the ratio is 0.539. Again, second function. And then I press cosine for my inverse cosine. And then I type in the ratio of 0.5389, close my bracket, enter, and I get a value of 57 degrees. I do the exact same thing here, second, and then I would press inverse for 10, 3.2106, close my bracket, and I get a value of 73 degrees, 72.6 or 73 degrees. And finally, sine C, so second function, sine 1 divided by 2, you could put 0.5, and we would get a value of 30 degrees. So if I have the trig ratios for angles of 0 degrees and 90, these can be determined using the ideas of rotation angles. So what a rotation angle is if I have an angle, let's say angle A, formed from a line, and this is going to be line R. If I start rotating counterclockwise, so in this direction, around this point, and we'll call this point O as shown in this diagram, then this is going to continue to form an angle. Now this side length R, if it started here, remains the same. So that's why this R here is the same as this R. So these are you can kind of picture this as the same line that's just being rotated from this origin here. So if I have this right triangle, AOB, so here's AOB, where AB is perpendicular to OA. So AB is perpendicular to OB, and so that we have a 90-degree angle being formed. And so that's what's happening in comparing diagram 1 to diagram 2 here. If I'm looking for the sine of angle A, that's going to be equal to y over r, where x is my horizontal length and y is my vertical length. And r is going to be the radius if I wanted to look at this as kind of like a circle. So similarly, cosine A, now remember cosine, if this is my angle, is, and so if we write our mnemonic here, SOHCAHTOA. So in relation to angle A, cosine A is going to be equal to adjacent over hypotenuse, and adjacent to this angle is side length x. And my hypotenuse, opposite of my 90-degree angle, and my longest side is side length r. That means that tan of A, tan is opposite over adjacent, is going to equal y, that's the opposite side, divided by adjacent, which is x, is equal to y over x. So as we continue to move my rotation angle, so as the rotation angle is made smaller, so decrease, then the opposite side of the triangle y, so if I bring this line down, then my side length y will also get smaller. And the adjacent side, x, will increase in value. So as this gets smaller, then that means that my side length x will get larger, it'll increase. So if a is equal to 0, that means it's been brought all the way down. Then the opposite side, y, would be 0. So if we bring this O to A all the way down in line with O to B, then y will equal 0, and r would equal 1. So r never changes the side length. It's always going to have a unit of 1. So that means that 0 divided by 1 is going to be 0. Cosine of 0 would be x over r. Now the side length is equal, or sorry, the length of x is equal to r. So that's going to be 1 is equal to 1, or 1. And finally, my tan of 0, if y is equal to x, or sorry, not y equals x, y over x, that's tan. Y is equal to 0, and x is equal to 1, therefore the value of tan 0 would be 0. Now we're going to be moving the opposite direction. So as my rotation angle A is made larger, so now we're going back up, then the opposite side of the triangle y increases in value. So if we're moving this line from here up, then my value of y will increase. And if that happens, then my side x will decrease. So this part here will decrease as this angle increases. So sine 90 degrees is equal to y over r. And in the context of this question, we're not necessarily saying that y is equal to 1, but let's say it equals 1. So 1 over 1 is equal to 1. All right. Now, so y is equal to 1 and r is equal to 1. Cosine 90, if we say that x is equal to 0, oh yeah, we are saying that y equals r. There we go. If x is equal to 0, we're going 0 divided by 1, and we're going to have a value of 0. But here, we have, let's say, 1 divided by 0. It's going to be undefined. So undefined. And we can check these in the calculator too, right? Like if I have sine 0, I have an answer of 0. If I have cosine 0, I have an answer of 1. And this is why. It's because of these ratios. Tan of 0 is equal to 0. Cosine 90 is equal to 0. And then tan of 90, domain error, undefined. Complete the following table, rounding if necessary to 2 decimal places. So I have all my angles, so x moving from 0 to 90 degrees. Now if I find the sine of all of these values to 2 decimal places, so sine of 0, we already know is going to be 0. As we move up, sine of 10, we get to 2 decimal places, 0.17, sine 20, moving up to 0.34, sine 30, 0.5, sine 40, 0.64, sine 50, 0.77, sine 60, 0.87, sine 70, 0.94, sine 80, 0.98, and then sine 90 we know is going to be equal to 1. Now, as the angle increases from 0 to 90, sine x increases from 0 to 1. So that ratio increases from 0 to 1. All right, last example here. We want to draw a right triangle, LMN, in which angle L is equal to 90 degrees and angle N is equal to x degrees. So here's my, my right triangle, something like this. And angle L, we'll call that L, is 90 degrees. And angle N, we'll call it that, is equal to x degrees. And then we have side length m. So we want to write an expression for the measure of angle m in terms of x. So recall that all the angles in a triangle add up to be 180 degrees. So 180 degrees would equal angle n plus angle m plus angle L. And we know that angle n is equal to x degrees. We don't know what angle m is equal to, but we know that angle L is equal to 90 degrees. And that all has to equal 180 degrees. So when we solve this, if we solve this algebraically, we'd have to subtract 90 and x from both sides. So in terms of angle m, 180 degrees minus 90 degrees minus x would equal that angle. So angle m is equal to 90 minus x degrees. Now explain using ratios why sine x is equal to cosine 90 minus x degrees. Well, I'm going to redraw my triangle just to really show what's going on here. So I had angle L, or triangle LMN, where this was angle x, and this is my 90 degrees. So if I'm looking for the sine x, we know that this is sine x, this is opposite, this is hypotenuse, and this would be adjacent. And I'm just gonna call this y degrees over here. So just the opposite angle. Now in order to solve for y degrees, I would have to combine 90 and x and subtract from 180, giving us 90 minus x, and that would yield angle y. So if I'm looking for sine x is equal to opposite over hypotenuse. And so my opposite side, we're just going to call that LM over hypotenuse, which we're going to call NM. So this would be sine x. Now if I wanted to solve for my cosine 90 minus x, 90 minus x, we're gonna say, well, this is 90, here's x. If I subtract those, that's going to give me my angle y. So cosine y, if we're using this as our reference point, cosine, this would then, if this is the angle in question, then this is going to become adjacent, and that's going to become hypotenuse. In which case, cosine, we'll call that y, or cosine 90 minus x, is going to equal the adjacent side, which is LM, and the over the hypotenuse, which is NM. And so sine x is equal to 90 minus x, or LM divided by NM is equal to LM divided by NM. Last, complete the following using an angle between 0 and 90 degrees. So sine 20. If I know that sine x is equal to cosine 90 minus x, my value of x is 20 in this context, and I know that sine 20 must equal 90 minus 20, which is 70. So those must have the same value, and we can check it here. If I go sine 20, I get a value of 0.34, and cosine 70, I have the same value of 0.34. And last, sine 8, again, this is my value of x, and then 90 minus x, we would have cosine 82 degrees.